Hello! Welcome to Rainier Learns Linear, an educational YouTube video where you can learn math, especially linear algebra, the easy way around, simple but straightforward. For this episode, we will be solving the determinant of a matrix product. By the way, I am Rainier Joseph B. Talite from BSCS 1CM, glad to guide you in this lesson. We are given two matrices, A and B. On our last episode, we have already solved for A, the determinant of matrix A, and B, the determinant of matrix B. Now, we will be moving forward to getting C, D, and show E, the matrix product of AB, the determinant of the matrix product AB, then prove the equality respectively. Let's start with C, the matrix product of AB. We are given AB, which is equal to 2, 4, 7, 0, 1, negative 2, 1, 1, 0, 0, 2, 1, 1, negative 1, 1, 0, multiplied to 6, 1, negative 1, 0, negative 1, 2, 1, 1, 0, 0, 1, 2, 0, 0, 0, negative 1. In here, we multiplied the elements of the matrices respectively. 2 multiplied by 6 plus 4 multiplied by negative 1 plus 7 multiplied by 0 plus 0 multiplied by 0. Then 1 multiplied by 6 plus negative 2 multiplied by negative 1 plus 1 multiplied by 0 plus 1 multiplied by 0. Then 0 multiplied by 6 plus 0 multiplied by negative 1 plus 2 multiplied by 0 plus 1 multiplied by 0. Then 1 multiplied by 6 plus negative 1 multiplied by negative 1 plus 1 multiplied by 0 plus 0 multiplied by 0. Then next, 2 multiplied by 1 plus 4 multiplied by 2 plus 7 multiplied by 0 plus 0 multiplied by 0. 1 multiplied by 1 plus negative 2 multiplied by 2 plus 1 multiplied by 0 plus 1 multiplied by 0. Then 0 multiplied by 1 plus 0 multiplied by 2 plus 2 multiplied by 0 plus 1 multiplied by 0. Then 1 multiplied by 1 plus negative 1 multiplied by 2 plus 1 multiplied by 0 plus 0 multiplied by 0. Then, for the third column, 2 multiplied by negative 1 plus 4 multiplied by 1 plus 7 multiplied by 1 plus 0 multiplied by 0. Then 1 multiplied by negative 1 plus negative 2 multiplied by 1 plus 1 multiplied by 1 plus 1 multiplied by 0. Then 0 multiplied by negative 1 plus 0 multiplied by 1 plus 2 multiplied by 1 plus 1 multiplied by 0. Then 1 multiplied by negative 1 plus negative 1 multiplied by 1 plus 1 multiplied by 1 plus 0 multiplied by 0. And for the last column, 2 multiplied by 0 plus 4 multiplied by 1 plus 7 multiplied by 2 plus 0 multiplied by negative 1. Then, for the next row, 1 multiplied by 0 plus negative 2 multiplied by 1 plus 1 multiplied by 2 plus 1 multiplied by negative 1 plus then 0 multiplied by 0, then 0 multiplied by 1 plus 2 multiplied by 2 plus 1 multiplied by negative 1. Then for the last row, 1 multiplied by 0 plus negative 1 multiplied by 1 plus 1 multiplied by 2 plus 0 multiplied by negative 1. After adding all of those values, therefore, we get that the matrix product of AB is 8, 10, 9, 18, 8, negative 3, negative 2, negative 1, 0, 0, 2, 3, 7, negative 1, negative 1, and 1. Now, let's solve for D, the determinant of AB. Since we already solved for the matrix product of AB, now we are going to get its determinant. So, what I did first is that I performed the elementary column operations to maximize the number of zeros in the row that I desire to use and expand. So, the operation or step that I utilized is negative 3 halves C3 plus C4 yields C4. Then, we are going to perform or apply the step that we had just established. So negative 3 halves multiplied by 9 plus 18 is equal to 9 halves. Negative 3 halves multiplied by negative 2 plus negative 1 is equal to 2. Negative 3 halves multiplied by 2 plus 3 is equals to 0. The negative 3 halves multiplied by negative 1 plus 1 is equal to 5 halves. Then, as I have achieved the most number of zeros in my desired row, I will use it and expand it. Then as we have expanded the chosen row, we will notice that the 3 terms are equivalent to 0. Therefore, we can cancel it out and equate it to 0. Then the only term left is 2 multiplied by negative 1 raised to 3 plus 3. Then its matrix, which is 8, 10, 9 halves, 8, negative 3, 2, 7, negative 1, and 5 halves. Therefore, we are going to perform the row operations or elementary row operations for us to achieve again the desired row or column with the maximum number of zeros for it to be easier to solve and shorter time to require. Then, the step that we have instructed is 10R3 plus R1 yields R1. So 10 multiplied by 7 plus 8 is equals to 78. 10 multiplied by negative 1 plus 10 is equals to 0. 10 multiplied by 5 halves plus 9 halves is equal to 59 over 2. Then, the next step is negative 3R3 plus R2 yields R2. Therefore, negative 3 multiplied by 7 plus 8 is equal to negative 13. Negative 3 multiplied by negative 1 plus negative 3 is 0. Negative 3 multiplied by 5 halves plus 2 is equal to negative 11 over 2. So as we can see, we can visualize the row or rather the column that we can use to expand with its most number of zeros. It is column 2. So as we expand it, we can also observe that 2 of the terms can be cancelled out and equated to 0. Then the last term is the one which we are going to use to solve for the determinant of the matrix product AB. So negative 1 multiplied by negative 1 raised to 3 plus 2. And its matrix 78, 59 over 2, negative 13, and negative 11 over 2. So in performing the cross product to get the determinant, we have 78 multiplied by negative 11 over 2 minus 59 over 2 multiplied by negative 13. Therefore, we get negative 429 minus negative 767 over 2. That is equal to negative 91 over 2. And as we multiply it to the outside products or the numbers that we get from the recent solutions, we get 2 multiplied by 1 multiplied by negative 91 over 2 is equal to negative 91. Then lastly is E. Show that the determinant of A multiplied by the determinant of B is equal to the determinant of the matrix product AB. So as we can see, we have solved that the determinant of A is equal to 7. Then the determinant of B is equal to negative 13. And the determinant of the matrix product AB is equal to negative 91. So if we multiply 7 by negative 13, we get negative 91, which is equal to the determinant of the matrix product AB. Therefore, as we can see, it is evident we have arrived at an equality. This set of solutions is correct. I hope you learned something great this episode. Thank you for watching and see you for the next session of Rainier Learns Linear. God bless!